This section is about the context window skills that actually matter in AI engineering, product, and agent roles. It's not just knowing that models have token limits, it's understanding the trade-offs those limits create. Employers are looking for practical systems, thinking how context affects cost, latency, retrieval strategy, memory, and architecture decisions. In other words, can you design AI systems that use context efficiently and reliably in the real world? Why does this matter? Because context window isn't just a spec to memorize, it's a systems skill. It affects product quality by defining what the model can actually reason over. It impacts latency and cost, since more tokens mean slower, more expensive calls. It also shapes architecture and evaluation, because long context systems need careful design and targeted testing. That's why employers value people who can design around token limits, not just quote them. Here's what the major providers actually document. OpenAI distinguishes between prompt and completion tokens, with models like o1 supporting up to 200K. Anthropic frames the limit as conversation history plus output, typically 200K, with up to 1 million on Sonnet 4. Google Gemini documents 1 million plus tokens and counts multimodal inputs like text, images, and files. The key interview takeaway is how each platform handles overflow differently. A bigger context window sounds impressive, but bigger doesn't automatically mean better. Long context models are now common, so just quoting a huge token limit isn't very meaningful on its own. What matters is the trade-off: cost, latency, retrieval quality, and whether the model can actually use that extra context effectively. In interviews, it's much stronger to discuss when long context helps, and when a more targeted approach works better. This slide is really about choosing the right context strategy for the job. Guest prefixes are best for stable, repeated content like system prompts, tool definitions, or policy documents. Retrieval-augmented context works well when the knowledge base is large and you only need the most relevant pieces at lower cost. Full context gives the highest recall, but it's expensive, so use it only when completeness matters enough to justify the token spend. Here's the key idea on token economics. Caching only helps if your prompts are structured for it. With OpenAI, you need an exact prefix match, so put static instructions first and variable content last. Their cache usually clears after 5 to 10 minutes of inactivity, and always within an hour. Anthropic and Google also reward stable prompt structure. Anthropic has premium pricing past 200K input tokens, and Google discounts reused cached tokens. Designing for cacheability lowers production cost fast. Here's the key research takeaway. A long context window does not guarantee reliable recall. The Lost in the Middle paper showed that models often miss or underuse information placed in the middle of long inputs, even when that information is clearly present. Anthropic's own model card makes a similar point. Long context can be unreliable. That distinction matters because serious AI engineers know the limits instead of just repeating vendor marketing. To mitigate long context failures, structure prompts so the most important evidence appears right at the beginning or end, instead of getting lost in the middle. For larger inputs, break documents into meaningful chunks and carry forward concise summaries across turns. Retrieval-augmented generation also helps by narrowing context to only what matters for the decision. And finally, test position sensitivity to see whether performance drops depending on where key evidence appears. Here are 3 practical skills employers actually test. First, token accounting. Estimate prompt size before runtime, then measure real usage after, using tools like TickToken, Claude's token counting API, or Gemini guidance. Second, prompt structuring. Put static content first and variable content last so exact prefixes can be cached. Third, truncation behavior. Platforms differ. Claude throws a validation error, while open AI assistants may auto-truncate threads, which directly affects product behavior. This portfolio strategy highlights projects that show real engineering maturity. In the document QA system, we compare full context prompting with retrieval, augmented generation on accuracy, latency, and cost. The meeting assistant keeps a rolling conversation state while summarizing older turns. The coding copilot caches repeated repository context and adds only the current task. And in the agent workflow, stable instructions stay in a cached prefix, while dynamic task state is injected each turn. What strong portfolio instrumentation looks like is evidence, not just a polished demo. We want token counts for prompt and completion usage on every request. Cache hit rate to show how often cached prefixes help. Latency percentiles like P50, P95, and P99 across different context sizes. Clear failure behavior near context limits. And position sensitivity evals showing whether answers change, depending on where facts appear in the prompt. That's much more convincing than a generic chatbot demo. For AI product roles, context window size is really a product decision, not just a model setting. Longer context can simplify the experience by letting users upload more material directly, reducing reliance on retrieval pipelines, and enabling use cases that used to be much harder. But there are trade-offs. Costs can spike, quality can become uneven at the edges, and you need pricing guardrails, fallback behavior, and strong observability. The real skill is knowing when simplicity is worth it. For AI agent roles, one of the biggest challenges is that agents accumulate state over time. As each turn preserves more history, the context window grows linearly and becomes harder to manage. Reasoning tokens also take up context space and are billed as output, so a lot of so-called agent failures are really context failures. Stale history, oversized tool traces, or repeated instructions crowding out what actually matters. This framework is about keeping an agent's context lean and useful. Instead of carrying the full conversation, we compress older turns into summaries. We keep only the artifacts that matter for decisions and discard tool traces or intermediate outputs once they've served their purpose. We also separate long-term memory from the active working context and cache-stable instructions like system prompts, tool schemas, and policy text in a reusable prefix. This slide compares full context prompting with retrieval augmented generation, or RAG. Use full context when the entire corpus fits in the model window. Cost is acceptable, and you need complete coverage, especially for static content that can be cached. RAG is the better choice when the corpus is too large, cost matters, or content changes often. By retrieving only the most relevant chunks, RAG usually reduces latency and keeps prompts much smaller. Here are the interview questions you should be ready to answer clearly. Be prepared to explain when long context is better than RAG, especially in terms of corpus size, latency, cost, and completeness. You should also cover cost reduction in multi-turn assistance through caching, history summarization, and retrieval. Expect questions about what happens when conversations exceed model limits and how to test whether a model can actually use important evidence buried deep in a prompt. Strong answers use the language of a serious candidate. They talk about token counting with both pre-ray-tied estimates and post-ray-tied instrumentation, caching strategy through prefix design, hit rates, and cost reduction, and truncation policy across platforms and downstream behavior. They also cover retrieval design, when RAG should narrow active context, and evaluation design, including systematic tests for long context failures. Don't just say a bigger window solves memory. Explain the trade-offs and propose experiments. This slide shows where long context knowledge is most useful across roles. For an LLM engineer, it's about token accounting, caching, and handling truncation. AI engineers use it to make architecture choices, like retrieval versus full context prompting. Applied scientists focus on evaluation and failure analysis. Product managers care about cost, UX, and observability. And for agent developers, it supports better memory separation, state compression, and prefix caching. Here's a simple 4-step career strategy for standing out. First, learn the official documentation, especially provider guidance and token limits. Next, build instrumented projects so you can measure token usage, caching, and cost. Then, run long context evaluations to uncover where systems fail based on position. Finally, explain your architecture choices in clear business language. That mix of knowledge, evidence, rigor, and communication is exactly what hiring managers look for. Don't just say, a model has a 200K or 1 million token window. That's table stakes. The stronger position is to show that you can translate those limits into real product and engineering choices. What to include, what to summarize, what to retrieve, and what to leave out. In other words, you're not just aware of context windows, you're using them strategically with data to shape better system design.